Hello viewers, today we will discuss about the structure and texture of the metamorphic rocks. I have already discussed about the metamorphism, type of metamorphism, phases, phase series, etc. Now let us see a broad classification of metamorphic rocks. We know already the type of metamorphic rocks and different process, particularly for the formation of different type of metamorphic rocks. We know already what is the difference between diagenesis and metamorphism. The diagenesis occur normally when temperature is below 200 degrees centigrade. Suppose we'll classify the metamorphic rocks, then on the basis of different type of metamorphism, we can classify the metamorphic rocks into 4 different types based on different type of metamorphic rocks, like the contact metamorphic rocks, regional metamorphism, then hydrothermal metamorphism, and mylonites. If suppose we'll take the contact metamorphism, normally in this case the intrusive rock is very important, and the country rock may be the sedimentary, igneous or metamorphic itself, and whatever the different zones are or areoles are developed, or in other words we can say different type of metamorphic rocks are developed, that all depend upon what are the types of intrusion as well as the host rock in which the intrusion took place. Particularly if the scrond rock is developed, so that must be in calcareous assemblies. Here in this case the temperature may be very high, even up to 1200 degrees centigrade, if intrusive body is your gabbroic in composition and normally pressure is very low. The regional metamorphism, which may be 2 types, the burial metamorphism as well as regional dynamothermal metamorphism. In burial metamorphism, the pressure is almost uniform and temperature is nearly more than 200 to 400 degrees centigrade, and normally the geolite facies rock form. Particularly in this case, if temperature is less than 200 degrees centigrade, then normally the diagenesis occur and recrystallization of mineral took place, and that is all the process of your sedimentary rock formations. The dynamothermal metamorphism, then in that case normally the pressure as well as temperature both are important, and all sort of structures normally we can observe in metamorphic rocks are developed during this process. Suppose we will see the hydrothermal metamorphism, so normally it took place in ocean basins or where the rock is having enough water, and particularly if mylonites, then normally it indicates the shear plane or fall plane. If suppose we will move from in country rock, then if there is any type of schistosity change, that indicates the mylonites, and that also indicates the shear plane or fall plane. What are the textures as well as the structures developed in metamorphic rocks? Let us see the textures. Particularly the textures is a very important part, because that give rise to how the rock is crystallized, what are the grain size, crystallinity, granularity, any sort of structures develop, minor folding, cystosity change. Then it's give a rock a proper shape with reference to grain size as well as relation, or better we can say, in other words, the mutual relationship, because that give a proper fabrics to the rock or a shape of the rock. If suppose we'll see the textures, then on the basis of that we can divide the metamorphic rock into 7 types. Now look at on the screen and see the different criteria on which we can find out the different textures as well as structures in a metamorphic rock. Textural denoting planar or linear elements, textures denoting planar features which deform the cystosity, textures denoting lack of preferred orientation or equidimensional grain, textures denoting large grain within the rock, and textures denoting inclusion within or rim on a porphyroblast, structures denoting concentric features, and textures denoting fragmental nature of whole rock. If suppose we will take the linear and planar structures, then on the basis of that we can find out so many structures which normally we can observe in a metamorphic rocks, like the foliations, cystosity, slaty cleavage, gneiss, etc. Now let us take the first case, that is the foliations. Now look at the diagram on the screen, particularly for the foliations. The parallel arrangement or distribution of minerals includes compositional layering and slaty cleavage, or in slates, cystosity as in schist, and compositional layering as in gneiss. In gneiss you can see there is a alternate light and dark color bands, which normally is shown by the light color is your felsic minerals, normally feldspar, plagioclase, quartz, etc., and the dark color bands by the mica groups, biotite, or maybe sometimes hornblendes. So this is also the structures, particularly in gneissic rock, are known as gneiss structures due to the presence of alternate light and dark color bands. As a foliation also this is known as. Suppose you will see in slate, normally easily we can see the slaty cleavage present, and particularly these slaty cleavages are mainly by the mudstone or clay minerals, sometimes even mica also. Particularly, if suppose we will see the phyllite, normally we can see the foliations present, and these all indicates particularly different structures normally present in metamorphic rocks that come under one part as a foliation also. Suppose we will see in details about the structures as well as the composition of these rock types. Now take the second structure, that is your slaty cleavage. Normally the slaty cleavage present in slates, and easily we can see the cleavage by the mica minerals or by the muds or clay minerals. Suppose we will see the foliation present in phyllite. In peltic rocks, these are by the clay minerals which later change into peltic rocks and mica grains. Suppose we will see the schist rock, the schistose structures. The schistosity, a parallel arrangement of mica or other platy minerals, giving a more or less planar structure as in schist and phyllite with a decrease in grain size. This grades to slate cleavage as in slates, stretch or stretch grains such as quartz in some strongly deformed quartzite or maybe form a schistosity. Slaty cleavage, the parallel arrangement of a very fine grain mica in a slate which gives its planar structure, the very fine grain equivalent of schistosity. Gneiss or gneissic layer, the alternate light and dark color bands, and normally the light color bands is by leucocratic minerals like quartz, potash feldspar, plesioclase, etc., and dark color band is normally by mica and hornblendes. Now next is your important structure, particularly lineations, and normally the lineations are present in metamorphic rocks, particularly by any sort of minerals which have a prismatic shape or tabular form. Normally the hornblende show as well as tourmaline show the lineation in a metamorphic rocks. Now let us take the second type of structures in which the schistosity is deformed. Normally the crenulation cleavage is present or kink bands are present. So here in this case, now look at on the diagram on the screen and see how the kinking or crenulation cleavage develop in a metamorphic rock. Crenulation of a schistosity or other cross lamination to form a new planar feature or a cleavage in the rock, sometimes called stem-slip cleavage. The third important type of structures, that is by the grain size orientations and grain size. Normally, if suppose you will see the different rock types as well as the textures and structures, particularly in this category, then normally we can see the hornfelsic textures as well as the granulose structures. Now particularly if suppose you will see the hornfelsic textures, then normally there is some sort of wrapping is present. Say for in case of andalusite present, then normally the andalusite is wrapped in a micaceous flax, and so the maculose structures. Here in this size, the ground mass is very fine, and in second case, normally the granulose, in that case we have a polygonal contact, particularly in marbles or in quartzite, because the grains are normally granular. This is also known as a saccharidal textures. In case of metamorphic rock, the terms porphyroblast are used, while in case of igneous, the phenocrest. When the porphyroblast or bigger grains are embedded in a fine grain ground mass, then the texture is known as a porphyroblastic textures. Here in this case, normally the garnet or sterolite is present. If suppose you will see the case here, the bigger grains of your garnet, is embedded in a fine grain ground mass of micaceous fabric. So here the garnet is known as a porphyroblast. In the similar case, you can see in this sample also the sterolites are present, particularly in micaceous ground mass. So here the sterolite is also showing a porphyritic texture as a porphyroblast, normally bigger in size as compared to other minerals. So this texture is known as a porphyroblastic textures. Now let us take the second important, particularly in this case, that is ideoblastic textures. And in ideoblastic textures, the mineral grains must be euhedral. Euhedral means whatever faces present, that means all faces are very well developed. And particularly the euhedral crystal, if embedded in a fine-grained ground mass, then the texture is known as ideoblastic textures. Suppose you will see the organ structures. So normally the porphyroblast is normally changed and stretched as an eye-shaped, and that is normally present in gneissic rock. In this case, the eye-shaped feldspar are embedded in a fine-grained ground mass. So this type of structure is known as organ structures. If suppose you will see the case of your porphyroblast, inclusion in porphyroblast, in that case, the porphyroblast have an inclusion of other minerals, and that texture is known as a poculotic porphyroblast. Particularly in that case, the bigger grains have an inclusion of your finer grains. If suppose you will see the reaction rims, then in that case, normally the phenocrest have a surrounding reaction rims. Let us see the thin section textures on a screen where the hyperthin plesioclase react and give rise to garnet plus CPX plus quartz. Here we can observe the reactions rims between OPX and plesioclase as a garnet. Now third important case, if any porphyroblast is react with water, then normally it can change into lower grade minerals. Normally if hyperthin is there, then that change into biotite. That also give a reaction ring, which is a low grade reaction ring or normally retrograde metamorphism. If suppose we can see this type of textures, normally the cataclastic textures are common, molar structure is common, and if suppose you will see the cataclastic, normally the finer grains are formed as a new minerals crystallize while crushing off the bigger grain size, and normally near the shear planes the fabric is changed from coarse to medium or even fine size. We can easily observe there is a gradation of grain size. If suppose you will see the molar structures, then in that case normally whatever porphyroblast are formed is normally deformed, broken and recrystallization and recrystallize along the boundary. So we can see the both new crystallized minerals of a smaller size as well as the bigger grains. So this type of texture is known as molar textures. Particularly suppose you will see the perthite antiperthite structures, normally due to any sort of inclusions. In case of, if suppose you will see the two feldspar system, normally when potash feldspar have a inclusion of plesioclase, that is your albite or oligoclase, then that texture is known as perthitic textures. And reverse case, when plesioclase have an inclusion of undigested part of orthoclase, then that texture is known as antiperthite. If suppose you will see the intergrowth particularly between potash feldspar and plesioclase with quartz, then normally the texture is your graphic or granopheric. So these are the common textures which are also present in metamorphic rocks. Normally, if suppose we are in granulate facies rock, we can observe the perthite and antiperthite textures with graphic textures. So these are the important textures, particularly in metamorphic rocks. Now let us see what are the important rock types particularly formed during this type of textures, and what are the difference particularly in this rock type due to presence of lineations, foliation, cystosity and nisosity. As we have already observed in case of nisosity, easily we can observe the alternate light and dark color band. In case of slate, we can observe the slatic cleavage, and similarly the flaky minerals show normally foliation as well as cystosity. Now let us see the case of your different rock types, particularly in metamorphic rock, which is also governed by the regional as well as thermal metamorphism and different type of structures, textures present in metamorphic rocks. Suppose we will see the granulite rock, particularly in peltic composition. So this is your condylite. Normally you can see the grains of garnet with fine needles of selemonite. Here we can see the granular structures within a peltic rocks of a granulite composition known as condylite. In a regional metamorphism of low to medium grade, we can observe the slate, phyllite, schist, gneiss and granulites. Particularly, if suppose you will see the rock type, normally the eclogites. In eclogites, we can observe the garnet with omphacite, and hornfelsic rock. If suppose you will see, then normally we can see the impure marble, then so many important minerals like diopside, wollastonite, ignestite, etc. are present. So in this way we can see the different structure and textures, particularly in a metamorphic rocks. Now it's the time to conclude the today's discussion. Today we have discussed something in details, particularly the rock type based on composition and also depend upon the type of metamorphism. And then after the microstructures and textures, normally the slate, slatic cleavage, lineations, foliations, cystosity, nisosity and different type of structures based on different conditions of minerals like porphyroblastic textures, ideoblastic textures, reaction rims, intergrowths, etc. And in my next lectures, I will take up the ACF diagram and AKF diagram. Now it's time to say goodbye to all of you. Thank you very much.